Hello, wonderful people! Here we are, section 32.2. We're going to talk about the law of conservation of charge. So here's a nice quote. In the matter of physics, the first lesson should contain nothing but what is experimental and interesting to see. A pretty experiment is in itself more valuable than 20 formula. And I agree. So, here is a very pretty experiment. Let's make that bigger. So here's this nice lady. I think she's a physics teacher. Um, I don't know. It was taken in a physics classroom. And uh, this little sphere that she's got her hands on, we have one of these in the back of our classroom. We actually have three of them. None of them work at the moment. And I swear the first thing I'm going to do Friday after school is order the part that you need to fix those. Now, that silver sphere is called a Van de Graaff generator, also the name of a famous band from the 70s. And she's got her fingers and hands on there, and that means that the electricity or the electrons or the charge, whatever you want to call it, goes through her hands, up her body, into her head, out her hair, and then out into the world. So that's the very short version of what's going on here. So the question I'm asking you is, well, why does her hair stand up like that? What is going on? Why does that do that? And why so much of it? I mean, that's impressive. Have you ever had your hair stand up? It doesn't stand up like this, right? Mine neither. Okay. So, oh, here are some better questions. What upward forces are keeping her hair up? How are those forces produced? Why do the hair strands spread out from each other? Why do they spread out radially from the head? Is hair a conductor or an insulator? We don't even know those words yet, but that's okay. And how can we find out? So, to understand what is going on here, we need a model of electricity, a model that makes sense, a model that explains what's going on. And that's what the next few weeks is all about. So, let's just cover some basics. What is charge? Oh, this is all under the introduction. Um, Electrostatics is the study of electricity when the charges are not in motion. And this is a good place to start studying electricity and magnetism because there are lots of demonstrations. Preliminaries: electrons, protons, neutrons, quarks. We'll talk about that later. All right. Just to keep on topic, this video is the law of conservation of charge. So, if you want some negative charge here in this box, there are two ways to make that happen. First, you create positive and negative charges out of nothing. So here's nothing in the box, and then we can turn nothing into a positive and a negative charge. And please note, they correspond 1-to-1. For every negative, there is one positive. One positive is one negative. There's no extras here. Remember this from the previous lecture? This is showing us that if you take a gamma ray and it comes just moving along and it gets pretty close to a nucleus, it's possible for that to split. And out of nothing, you make a positron and an electron. So there's no particles over here, and over here, there's two particles, the positron and the electron. The positron has a charge of +1, the electron has -1. So before there was a total charge of 0, after there's a total charge of 0, because +1 and -1 added together is still 0. So you can make a bunch of negative charge out of nothing, provided there's the same amount of positive charge. That's the first way to get some negative charges in this box. Second, get some negative charges that already exist somewhere out there in the world and drag them into the box. So look, oh, way back over there, there's some negative charges. And here's my empty box. So I'm going to grab those and then I'm going to do work. Remember work? It's a physics concept. And drag those negative charges into the box. Now I have negative charge in the box. Now, where did these negative charges come from? Well, they came from somewhere else, but I tell you this, wherever these charges were made, positive charges were also made. And if you add up all the negative charge in the universe and all the positive charge, it all adds up to exactly zero. Okay, we already talked about that. So what is the law of conservation of charge? You can't create a single negative charge out of nothing. That is breaking the law. All charges are conserved. So you can't create charges other than in pairs of positives and negatives. You can't just create a single negative charge out of nothing. So you see how those relate? Similarly, you can destroy a charge, but only by combining it with the opposite charge and having them both disappear. So if you want to kill a minus, you have to combine it with a plus, and they both go away. You can't take a negative charge all by itself and just destroy it. You can't crunch it up and turning it into dust. Nope, that negative charge is just fundamental. You can't just create, all charges are conserved. So that its negative charge is conserved. The only way you get rid of it is if you combine it with a positive charge and they both go away. That's what it means to be conserved. All right, this is a pretty picture. That's a pretty picture. Electrostatics is based on these things. We'll talk more about that later. Coulomb. Any other good pictures? I don't think so. Okay, thank you very much.